discuss the example of derivatives of hyperbolic function. So first, we all know the sum of the formulas of derivatives of hyperbolic functions. So first is the derivative of sine hu is equals to cos u du. And second is the derivative of quantity of cos u, and that is equals to sine hu du. Then the derivative of tan, so tan hu, that is equals to secant h squared u du. Okay, so the derivative of cos hu, that is equals to negative cos secant h squared u du. Then the derivative of quantity of secant hu, that is equals to negative secant hu tan u du. Then next and the last is the derivative of cosecant hu, and that is equals to negative cosecant hu cos hu du. No? Okay. So for example, if you given this problem of the hyperbolic function, no? So y is equals to the cosine h, then the quantity of 2x plus 1. Okay, so again, what is the first derivative of y is equals to cosine h 2x plus 1, no? Okay, so let's say u here, that is equals to 2x plus 1, then du here, that is equals to 2. Okay, so again, our derivatives of hyperbolic functions formulas in terms of cosine h, that is equals to sine hu du. So therefore, our y prime, or the first derivative, that is equals to sine h quantity of 2x plus 1, then we get the du, which is 2. Okay, or to finalize our answer, that is equals y prime, that is equals to 2 sine h quantity of 2x plus 1. Okay, so that is the final answer. Again, another problem, number 2. So for example, we get this problem given y is equals to sine h, which is tan x. Okay, so for example of that, no? Okay, so let's say you here, that is equals to tan x. Okay, derivative of tan u, that is equals to secant squared u du. Okay, so therefore du here, that is equals to secant squared x, no? Then so to solve or to find the first derivative, so we use this formula, the derivative of sine hu, that is equals to cos u du. Okay, so therefore y prime, that is equals to cos u, where u is tan x. Okay, tan x, then times du here is secant squared x. Okay, so to finalize our answer, so y prime, that is equals to secant squared x, then cos tan x. Okay, so that is the final answer. Okay, so another is y is equals to the tan h, then we have 1 minus 2x squared. Okay, so what is the first derivative of this given, no? So let's say u here, that is equals to 1 minus 2x squared. Then where du here, that is equals to negative 4x. Okay, 4x. So again, since we have the derivative of the constant is 0, then we obtain the sign, no, which is negative. Then we derive 2x squared, that is negative 4x. Okay, then we use this formula, the derivative of tan hu, that is equals to secant h squared u du. Okay, so therefore we can now obtain the equivalent first derivative of this problem given. So we have the secant h, then where u here is 1 minus, or this can be squared, secant h squared, then 1 minus 2x squared, then times negative 4x, or we can write, so negative 4x, then we have secant h squared, then quantity of quantity of 1 minus 2x squared. Okay, so that is the final answer. So another example, if you given y is equals to the cotangent, okay, cotangent h times e to the power 4x, okay. So again, if you given this y is equals to cos h, quantity of e to the power 4x, this is 4x. Okay, so let u here, that is equals to e to the power 4x. Then to find du, that is equals to the e to the power 4x, then we derive 4x, so times 4 here. Okay, so again, the derivative of cos hu, that is equals to negative cos secant h squared u du. So therefore our first derivative is, that is equals to the so that is equals to cos secant h squared, then where u here is e to the power 4x, then times which is du, that is equals to e to the power 4x, then we have times 4. Okay, so or to finalize our answer, so y prime, that is equals to, so negative 4 e to the power 4x, then we have cosecant h squared, then quantity of e to the power 4x. Okay, so that is the final answer. Okay, so another problem, what is the first derivative of secant h, the quantity of sine squared x plus cosine squared x times 2x squared. Okay, so in the problem given, sine x squared x plus cosine x squared, this will be equals to 1 according to the trigonometric identities. Okay, so this will be secant h, then 1 times 2x squared. Okay, so therefore our given or new given that it will become secant as h, then we have 2x squared. Okay, then let u here that is equals to 2x squared, then du here is equals to 4x. Okay, then take note, we use this formula, the derivative of secant hu, that is equals to negative secant hu tan u du. Okay, so therefore y prime that is equals to negative secant h, our u is 2x squared, then tan h. Okay, then we have 2x squared, then where du is 4x. So therefore y prime is equals to negative 4x, then secant h 2x squared, then tan h, then we have 2x squared. Okay, so that is the final answer. Okay, so another example problem is y is equals to cos secant h quantity of ln x squared. So what is the first derivative, no? So let's say u here that is equals to ln x squared, then du here that is equals to the derivative of ln x squared. So take note, we use this formula, ln u, then that is equals to the du over u, no? Okay, so to derive or to find in this case to find du, so we must take the derivative of x squared, so that is 2x, then we have x squared, then where du here, that is we can simplify now, so we have 2 over x. Okay, so again take note that the derivative of cos secant h u, that is equals to negative cos secant h u, then cot h u du. Okay, so let's say we review the formulas. So this is negative cos secant hu, then cotangent hu du. So y prime that is equals to negative cos secant h, then where u here is ln x squared, then cotangent h, then we have ln x squared, then where du is 2 over x. Okay, so to finalize our answer, so we have negative 2 over x times the cosecant h, then we have ln x squared, then we have cotangent h, then ln x squared, no? Okay, so that is the final answer.